Okay, we're going to look at question number 5. This will be only on the AB exam. Let me double check that really quick. Let's see. I'm just going to look at the screenshot. So it's yeah. So 5 and 6 are going to be strictly AB questions, and I have not read the question yet. So I've only looked at just enough of it to know whether it's a common question to A, B, and B, C. So you're going to get to see me solve this in real time, and we will see how this one goes. Some of my students did say that 5 and 6 were challenging problems. A lot of times that's because of mental fatigue. You've been sitting there for 3 hours and you're tired of working on calculus questions. So let's see if it was as bad as you think. And wow, look at the size of that table. All right. I did not predict this one. This was one of them that I didn't predict. Okay. F and G are twice differentiable. So I'm going to go ahead and make a note to myself right now because this may come into play later. They tell you that F and G are twice differentiable. So because F and G are twice differentiable, F prime, G, and G prime are all continuous. Okay, just throw that out there. They give you a bunch of values, and you have to be very careful on problems like this not to accidentally pull from the wrong spot. And A at a glance looks ridiculously nice. H is F of G. Find H prime of 7. Yeah, this is an extremely nice problem. You're finding the derivative. Make sure you write the derivative first. And this is your textbook definition of the chain rule. So boom, there's 1 point. And boy, was that easy. H prime of 7 is going to be F prime of G of 7, G prime of 7. And we just have to be careful not to accidentally pull from the wrong spot. So F prime of G of 7, there's G, F prime, that would be a 0. G prime of 7, I'm just going to leave it G prime of 7. And now F prime of 0 looks to be 3 halves. G prime of 7 is 8. And that ends up being 12. But what if I mess that up? I'm going to cross it out just in case there was a mistake there. And that was extremely nice. Extremely nice question. So hopefully you were not so put out by the length of the AP exam that you did not capitalize on that question. Everybody should have gotten that one. K is a differentiable function. That is this thing. Is K concave up or concave down? And boy, this one now on the surface looks like it's going to take quite a bit of time because I see a reference to concavity, which means I need the second derivative. And boy, is this going to take a little bit of time because the first derivative is a product rule with a chain rule inside it. And then I have to do the second derivative. Yowza. All right. I don't think there's a difference between a difficult question and a long question. I believe this one is a long question. So, whoops, this is K prime. So the derivative of, how nice. They gave you K prime. Scratch what I just said. This just got significantly easier. I glanced at this and I thought this was K of X, but it's not, it's K prime. So if I need the second derivative, we only have to do one derivative of this, which still is a product followed by a chain or product with a chain inside it. But it really did just get nicer. So my product rule, I do the derivative of the first function first, which that is a chain. So that'll be 2 times. I will leave the f of x alone to the first power times the derivative of the inside. All of that is the derivative of f squared. I'm going to leave g alone. Plus now I'm going to leave f squared alone. And the derivative of g, we will plug in 4. Hiccup! Which is 2 f of 4, f prime of 4, g of 4 plus f of 4 squared, g prime of 4. And I need to work this out until I get to a point where I know this is positive or negative. So f of 4 is 4, f prime of 4 is 3, g of 4 is negative 3. Plus f of 4 squared is going to be something positive, but just how positive, that is f of 4 is 4. So that'll be 4 squared. I believe that's 16 today. I'm not sure though. G prime of 4 is 2. And we do have to keep going. So I was hoping that they would both be negative or both be positive terms, but that didn't happen. So that is 8 times 9 is negative 72. 16 times 2 is 32. Negative 72 plus 32 is less than 0. Therefore, or I'm just going to say this. I'm not going to say therefore. I'm going to say that K is concave. I'm double checking the question to make sure I'm answering the correct question. Yes, K is concave down at x equals, and we are looking at x equals 4 because K double prime of 4 was less than 0. Nice question. Not as bad as I was thinking it would be. Let M be that function, and we need to find M of 2. Okay, so M of 2. First, I'm just going to plug in 2 for my x. That's 5 times 2 cubed. This is a mother-in-law problem. This is a mother-in-law problem. For you random internet people who don't know me, a mother-in-law problem is one that looks really bad. It looks scary and intimidating, and you just don't want to be around it, just like a mother-in-law. But then once you get to know your mother-in-law, it's not as bad as you think. This problem is a lot scarier looking than it is in practice. So M of 2, I'm just going to plug in 2 for my x's. Now I have to stop and analyze that, figure out how I'm going to evaluate this thing. Well, 5 times 2 cubed is 5 times 8. And then for the antiderivative, we're evaluating an antiderivative. That means I need to find the antiderivative. The antiderivative of f prime is capital F, evaluated from 0 to 2. That's going to be 5 times 8 is 40. I usually don't simplify, but I feel pretty confident that 5 times 8 is 40 today. Plus, and then f of 2, plug in the upper limit, minus f of 0, which is 40, plus f of 2, back to the table. F of 2 is 7, minus f of 0 is 10. And that would be, I believe, 37, but don't risk it. Nice question. Nice question. It's one that if you look at it, you're suddenly going to get very scared, and you may just be like, but that was a nice question. This is why you don't let the length of the exam intimidate you, because there are sometimes questions that look bad but are not as bad as they look. Is the function M defined in part C increasing or decreasing or neither at 2? So whenever I see a question asking if a function is increasing or decreasing, I immediately think, is the derivative of that function positive or negative? So I'm going to start by finding M prime of x. And M prime of x, well, the derivative of 5x cubed is 15x squared. The derivative of the integral from 0 to x of f prime of t would be f prime of x, technically times 1. You always want to multiply by the derivative of the variable that replaced the t's in that fundamental theorem of calculus approach. So now I am determining whether this function is increasing, decreasing, or neither at 2. So 15 times 2 squared plus f prime of 2 is going to be 15 times 4 is 60. F prime of 2 is negative 8. That would be 52. That is greater than 0, therefore, and it's going to be very similar to how I answered B. Therefore, M is increasing at x equals 2 because, and I probably should write the word because. I wrote it here too. Earlier in another question, I wrote B/C. I was lazy. M is increasing at x equals 2 because M prime of 2 was greater than 0. And we are done. We are done. That's kind of a nice question. It wasn't brutal. It's just towards the end of the exam, so people tend to make it more difficult than it should be.